Hi, so this appears in chapter 4 from the book Introduction to Algorithms, CLRS, and maths crossing Subarray. The core idea is that you make free comparisons, right? Here you can see that you make free checks of either maximum Subarray from the left side. So imagine that you start here because this will be the midpoint, right? So you start in the mid and you ask three questions. Is the maximum subarray? So what you want to do in the maximum subarray is to find the sequence of numbers that has to be consecutive. Let's say this, right? -1, 3, 4, -5, 9, 2, and then you want to see where does that sequence start and where that sequence ends. So here's the solved algorithm, and what you can see here is that when I run this, it should return me the start and the end as well as the sum. Right, now we know that the subsequence can be either from the midpoint, which will be q divided 2, right? And from the midpoint, we check if it's on the right or left, or if the subsequence includes that mid value. And for that, we have to understand this problem, which is the find maximum subarray. And what you do here is that, sorry, not this one, this one, find match crossing subarray. So what you have here is that what you do is that you split the array in two, right? And you can see that I have two for loops. And what I want to find is the match left, which will be this one, the right sum, and also the sum, right, which is restarted at each of the points. So this will be here, and this one will be here. And what you do is, for example, here, right? So you start from the midpoint and you start going to the left. And the left, you can see that if it has a 4, then you add, this is the sum, right? So you add a 4 to the sum, you add a 3 to the sum, which you will have 7, and then you add a -1. So the largest of these sums is 7, which happens on 3 here, right? So what you save is the index, in which this will be index 1. So you save that here to left sum, and you can see here in the algorithm that it goes counting down, and whenever the sum is the maximum, it updates the left sum to be, in this case, 7, and the maximum left, which is 1. So now we know that this should be end result 7 and 1, and then we do the same for the right, so -5 will be -5, we add the 9 will be 4, and we can see that this is the maximum, right? After this is 2, so the right sum will be equals to 3, 4, 5, so it will be 5, and the sum from the right side will be equals to 4. All right, and then what you do is that you return the sum of it. Something interesting here is that, never mind. Okay, so now you return the sum, which will be from here to here, and also which is the left and which is the right. And you do that, so that will be find match crossing, which is asked here and here. But what you do here, sorry, not here, here, which is done here, and what you do here and here will be recursively calling this function from the left, asking to the left and to the right. So what you ask is run the find match, almost, and you can see this is almost like a binary tree, right? So you ask the left and right, and once it completes everything, it will return the left and right values, right? And then it will compare it to the maximum subarray from the midpoint, right? So you will be running this, and if it includes it, you will compare it, and then you will return the maximum subarray. And here you can see a if statement, but this is a little bit cumbersome. What it really means is like return match, and then you have the sums, and because the problem is that you also have to return left and right, so that's why you have a if as if. But what you do is that you return the sums, and the sums will be from here, right? So it will be the left sum, right sum, and cross array. Of course, you also include the cross high and cross right. That's why you don't have this, but you have this syntax instead. But basically here, the simplification will be that then after checking for these three cases, either this one, and this one, in which it doesn't include the midpoint, it does include everything before, it includes everything after, and you can see that it is recursive, right? So what it will be doing is that then it will ask, as a binary tree, it will ask from starting from the midpoint, it will try to check here, here, and here, and then it returns it up. So that's divide and conquer solution for finding the maximum subarray.